The difference between the mode shape and normalized mode shape primarily to their scaling and interpretation in dynamic analysis. Here's a detailed explanation we will see tailored to cantilever beam problem. Mode shape means mode shape is a mathematical representation of the deformation of the structure at a specific natural frequency. For a specific natural frequency, how it will become, the deformations will happen, that we can see it. It describes how each point along the structure moves when it vibrates in that mode. For a cantilever beam, the mode shape indicate the pattern of deflection along its length. That's right. The first mode shape, we can see this is a 3 by L x minus x squared by 2L. This equation gives absolute values of deflection at different points along the beam, where the maximum deflection typically occurs at the free end. Suppose if I put 4 meter length of a cantilever beam, 5 1 of 4, this will become 3 by 4. Here 4 minus 4 squared by 2 into 4. This value, it will become 1 by 1.5. But a normalized mode shape means, a normalized mode shape on the other hand is a mode shape that has been scaled so that its maximum deflection or some reference point is set to specific value, often 1. Normalization helps to compare different mode shapes more easily and ensures consistency in representation. For instance, normalized version of the first mode shape could be phi 1 of x divided by max of phi 1 of x. This I will explain a little bit clearly. Suppose if it is 4 meter, this will become 4, right? This is 4, x equal to 4, x squared equal to 16, 16 divided by 8. 2 into 4 is 8. So this will become 2. 4 minus 2 equal to 2. So 3 into 2 divided by 4. That means 6 divided by 4, that is 1.5. So phi 1 of x will become 1.5. But this 1.5 we need to normalize it. So phi 1 of x, whatever it's coming, divided by max value. Max value is 1.5. So here it will become phi 1 of x is 1.5 for the first mode. Divided by max is 1.5. So it will become 1. So this phi 1 of x for for example x equal to 2, that location, this has to be normalized divided by 1.5. So if we can see this one as an example, we can. So here you can see this value is the normalized value 1.5, and this is the absolute value 1.5, and this is the normalized value because we have divided that 5 value divided by 1.5. So at 2 meter, if you see here, this value becomes 2.04, but here it becomes 2.04 divided by 1.5. that will becomes like a 0.75, right? So here it's 2 meter 1.125. 1.125 becomes 0.75. So we are dividing it by 1.5 times all along the length. That's how it's normalized. Here we can see along this length 0 to 4 meter, 0 to 4 meter length, we are getting a maximum 1.5. So normalized will be this value divided by 1.5, we are making it. So 1.5 we are dividing it, that's why this is normalized to 1.5. Suppose if it is mode 2, maximum value, it becomes 0.7. Here you can see 0.707 at the distance of 1 meter, right? So that's the maximum, and then it goes to the negative also at 4 meter. If you see it here, it's 0 value it comes, and here it's minus 0.707 at 3 meter. These are the two nodes also it will come. If you see the 0 value also, it's the 0 value, it becomes that node, right? We have seen there will be a node. This is 0.044. There will be a node at 8 into 10 per minus 1. That's a node at 2 meter. If we can see this as a mode 2, if we change this to, this is the mode shape 1. If I change to mode shape 2, this is the mode shape 2. A normalized mode shape, we can see it here. Normalized mode shape, it would look like this is the normalized mode shape. We are making that 0.70. We have seen at 1 meter it is 0.707. So we need to change normalized to 1. So 0.707 divided by 0.707, it becomes 1. So the entire phi 2 we are normalizing it, and here at 2 there is one node. The node means the point along which 0 displacement is there. So this is a normalized mode shape 2. This is the normal mode shape, absolute mode shape 2. If we take it to the mode shape 3, this is the mode shape 3, and we will see the normalized mode shape 3. This is the normalized mode shape 3. At mode shape 2, this value, maximum value, it becomes 0.71 at the point 2. There are two nodes, here one node and here one node. At the node of 0 it becomes 1.36 roughly, and here it becomes 2.68. There are two nodes like that. If we can see the here we can see the code for this one. First we will add a mode shape 1, that's the seat name, we are adding it, and then all the contents we are clearing it, and output row starting with the 1 itself, because we are starting with the length 4 meter, number of points 1, output row 1. So we have added a seat mode shapes in that, all cells will clear it. Row 1 of 1 we are writing position, then mode shape 1, normalized mode shape 1, mode 2, normalized mode shape 2, and mode shape 3, normalized mode shape 3. I equals 0 to number of points 100, L divided by number of points is the value, like this we have seen already, 3 by L into x minus x squared by 2L, and mode shape 2 will be square root of 2 by L into 2 pi by pi x by L. Mode shape 3 equal to sine square root of 2 pi L into sine 3 pi by x by L, that we have seen it. So output row is output, we are writing it output second row plus 1, that first value it should come x, and the mode shape 1, 2, 3 we are writing it. After that, this is, it will write all these values 1, 2, 4, 6. In between we have 3 and 5 for written for the modes, normalized mode shape 1, normalized mode shape 2, like that we are writing it, right? So 3, 5, 7, these values will become normalized 1. So find the maximum value of normalization. We can see max phi 1, worksheet max phi 1, we can get max phi 1, and max phi 2, max phi 3 we can get it. The worksheet function is there max. So for I equals 0 to number of points, it has to write output, it starts from second row. So mode shapes of output row, this is the third column, it has to write the max of phi 1, it has to divide it, and fifth one max of phi 2, seventh one max of phi 3. That with the seats mode shapes column A to G, it's writing this format. We are writing all this format of how we have to solve it. That max mode shape normalized value, it's done.